The main campus here is largely a research campus with laboratory facilities, physical plant to operate. We do have residential student housing here on campus. A lot of people don't know that. And kind of plant growth facilities and everything necessary to actually do research on tree fruit. The majority of the facilities on campus are, we'll call them pre-World War II, World War II, and Korean War vintage. And for a modern research facility looking forward into the future, that does present some challenges. So there's historically been a lot of really important work here that's supported the tree fruit industry, but there's a lot of work that can't be done basically because of facility deficits at this point in time. So that's really the challenge that we're sitting in today.
For today, we've got some apples from a company in Quincy. We got some pathogens from the companies, and we want to see if that pathogen causes some food safety issues in post-harvest systems. In 2020, there was a report from some of the packing houses in Washington State that there was asymptomatic contamination of apples. So when they went to the lab to measure, they saw that there was high pathogen content in apples that doesn't have these symptoms I showed you earlier. So now what we did was to go to those companies, grab some of their stuff, and come to our lab here. We smash them open, culture them, and we see some growth from those apples, which looked asymptomatic when we got them in the first instance. So we want to see if this asymptomatic contamination is widespread or is localized, or there are other pathogens apart from what we know that is causing it. So maybe there are some other cryptic fungal species that might be involved that we don't know. So it's a wide range of things. So we want to see epidemiology, fungicide sensitivity, and to what extent do they produce this pathogen, and what are the genetic factors that cause that made them to behave this way. So we want to test them on these apples now to see if we get the same thing. So it's called Koch's postulate in biology. So you first of all go into the disease system, get out the microbe that's there, and see if it causes the same thing. So you have to, that's how you verify that that is what is causing the disease.
In our case here, last year we replaced the steam line that provides heat to this main facility you're standing in right now. That's, I think, the third time it's been replaced since the building was installed. And they're saying they'll probably never do that one again because technology changes, but unfortunately, the way things have been coming, we're only getting to emergencies at this point in time with the funds that are provided by the state. Some of us are thinking that we've gotten to the point where we're so far past the point of repair on a lot of things that we're actually probably more economical to simply scratch old and start new. We also have a complex down in this part of the campus that's really focused on entomology programs primarily, and also our plant growth facilities. And we have about 7,000 square feet of greenhouse space, which again, vintage World War II, Korean War. It's basically the poorest quality greenhouse space in WSU. We need more controlled atmosphere facilities in order to do the research and experiments that you would think need to be done in order to be ready to manage crops 20, 40 years down the line. So you think about things like the heat dome event from a couple of years ago, or other kind of extreme weather events. When you get that one time in the field, you get a lot of anecdotal information about what happens to the tree. But if you want to repeat that and understand what are the impacts, you need to be able to go inside a greenhouse and control the environment and essentially do replication to see, did what we see, was that like a one-time thing that you know, noise in the data, or is this something that we need to be better prepared for in the future? So the new facility that we are designing really brings all those capabilities. We'll have significant control on temperature, atmospheric chemistry, humidity, moisture, all those factors that right now we got a building with glass that has some heat that we can grow some plants in, but to be able to experiment in is just not going to be there. Tissue culture lab and controlled atmosphere, or controlled storage, cold storage, and growth chambers and things like that, and also working space. Cold rooms, dark rooms, growth chambers, dry storage, more mechanical room, workspace, dirty work area, so that you can drive in and drop things off. Storage, chemical storage, tissue culture lab, kind of everything you need to actually have a fully contained, everything we need to do in terms of growth and experiment with plants, we can do it in that building. And actually what it will do is it'll provide some relief on other space needs that we have in our existing facilities that we do plan to use for the next 40 years, because we'll just move certain things out into that space. Cost projection in the recent construction and economic environment has been a very, very challenging thing. So we're assuming this is an $18 to $20 million build to build it out and supply it and make sure it's ready to actually use. So I'll kind of, from this vantage point out where you see the sign in the field out there is where the plant growth facility is planned for. And the city's going to update spring water this year all the way up to the Coug house. You want to get ready to take something into the greenhouse for an experiment. You basically start here and work on it, and this is part of what the new facility plan actually has, is make these spaces much more functional and usable so that you can do everything related to work that ultimately the plant's growing in the greenhouse. But this is one of the structures I want to go away, and so it is a greenhouse. It does have atmospheric controls. It does have irrigation and misting, that kind of thing, but it's just not in great shape, and it's really honestly poorly designed too. So it's not super functional to run a number of experiments. You'll see that the benches are essentially homemade benches. They're not real smooth, and when you go into a new facility, you'll find that benches are set up that they're rolling. So you might have a situation where a room half this size is actually a large enough unit room to work on the same number of plants for an experiment. And so in a room this size, you could potentially have twice as many plants and functionally use it and do 2 experiments instead of just 1. So this is where the new facility would go. And the greenhouses would be on this end, and the main part of the head house on the other end. One thing you do have to think about in a university setting is, the time horizon of planning that you're looking at is, sometimes you're doing things in the next 6 months to 5 years, but at a campus like this, you really have to be thinking about 100 to 250 years. What are you doing with it?